We are covering the fundamentals of traffic flow, specifically the speed-density-flow relationship and the Greenshields model, a key topic in the transportation engineering section of the FE Civil exam. The three core variables you must master are flow, density, and speed. Flow, represented as Q, is the number of vehicles passing a point per hour, with units of vehicle per hour. Density, K, is the concentration of vehicles on a roadway, measured in vehicles per mile. Speed, U, is the space mean speed in miles per hour. The fundamental equation that connects them, found in the transportation section of the NCEES reference handbook, is Q equals U times K. This relationship is intuitive. The rate of vehicles passing a point is a product of how fast they are going and how closely they are packed together. The exam tests this relationship using the Greenshields model, which simplifies the interaction between speed and density into a linear equation. U equals UF times the quantity 1 minus K divided by Kj. In this model, UF is the free flow speed, the speed you could drive on a completely empty road, and Kj is the jam density, which is the maximum possible density when vehicles are stopped bumper to bumper. This linear model for speed leads to a parabolic model for flow when you substitute it back into the fundamental equation Q equals U times K. This results in the equation Q equals UF times K minus the quantity UF divided by Kj, all times K squared. The single most important thing the FE exam will ask is to find the maximum flow, also known as the capacity of the roadway. This occurs at the peak of that parabolic flow density curve. You could use calculus to find this maximum, but for the exam, you need a shortcut. Here is the most valuable takeaway. Maximum flow occurs when the speed is exactly half the free flow speed, and the density is exactly half the jam density. This leads to the memorable phrase, max flow is at half and half. Let's apply this to a typical exam problem. A highway segment has a free flow speed of 60 miles per hour and a jam density of 140 vehicles per mile. What is its capacity? Using our shortcut, the speed at capacity is half of 60, which is 30 miles per hour. The density at capacity is half of 140, which is 70 vehicles per mile. Now, apply the fundamental equation. Qmax equals 30 miles per hour times 70 vehicles per mile, which gives a capacity of 2,100 vehicles per hour. A common exam trap is to give you a specific flow rate and ask for the corresponding density. Remember that because the flow density curve is a parabola, any flow rate below the maximum capacity corresponds to two different densities and two different speeds. One is on the left, uncongested side of the curve with high speed and low density, and the other is on the right, congested side with low speed and high density. The question might specify congested conditions to guide you to the correct answer. Always double-check your units. The exam may mix vehicles per hour with vehicles per minute or miles with feet to try and trip you up. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.